Okay, welcome along to some alcohol questions. So same as before, we'll go through each question, pause it, see how you get on, and then I'll go through the answer. So here's the first question. So we need the simple equations for the formation of ethanol by fermentation and also for the complete combustion of ethanol. So give that a go, see how you get on. So first of all, we're going to give it for the formation of ethanol. So by fermentation. For fermentation, we start off with glucose, which is C6H12O6. And that goes to C2H5OH, which of course is our old friend ethanol, plus CO2. And to balance it, you need two of those and two carbon dioxides. For the complete combustion of ethanol, this should be quite straightforward. We're going to start off again with C2H5OH for ethanol. We're going to add O2. If it's complete combustion, we're obviously going to make CO2 and H2O. Now we balance these in exactly the same way as we were doing for the alkanes complete combustion. We've got two carbons there, so I need to have two carbon dioxides. I've got a total of 6 hydrogens there, so I need 3 H2Os there. Now we need to think about balancing our final O2. So over for our carbon dioxide, we've got 4 in total plus 3 there. That gives us 7. But remember, you've got that O there. So to get this to balance, I need 3 O2s. Forgetting that oxygen is a common mistake, so don't do it. Okay, well done. Let's carry on. Okay, so what we're going to do now is we're going to give the equation and the conditions for the industrial manufacture of ethanol. So this would be how we would make it in the UK. So, for example, so let's give that a go. So first of all, we're going to start with ethene. So that's going to be C2H4, and that's a gas. And we react it with steam. So that's also a gas, and that gives me nice and easy ethanol. Now obviously the reaction is done above 100 degrees C because water must be in the gaseous form as steam. So one of the conditions would be above 100 degrees C, and we also use an acid catalyst to get it to go as well. Okay, well done. Right, so we're going to complete these equations now for oxidation using acidified potassium dichromate solution. Right, so we've given you part of the equations, so we need to balance this out. So for number one, we're starting off with ethanol again, and we're adding 1 oxygen. So that's going to give us, if we're adding 1 oxygen, ethanol of course is a primary alcohol, that is going to give us an aldehyde. So that will give us CH3CHO and of course H2O. The next one, we're adding 2 oxygens, so that's going to go through the aldehyde and carry on to give me the carboxylic acid. So that's going to be CH3COOH for the carboxylic acid. I've obviously made water as well because I've gone via the aldehyde. For the next one, so this is an in-between ones, I've got the aldehyde, I'm adding 1 oxygen, so that gives me the same, but now this is only going to give me the carboxylic acid. And you can see that if you have a look at the atoms we have on the left hand side, we don't need to make any water to make it balance. That's quite handy. And finally, we are starting here with a ketone. So we won't actually have any reaction, will we? So no reaction. That was a little bit nasty. Because obviously ketones cannot be oxidized any further. How would the reaction conditions be different in 1 and 2? So in reaction 2, I'd obviously use, so in 2, I would use excess potassium dichromate just to make sure it goes, and I'd also reflux to make sure it goes to the carboxylic acid in number 2. And what we'd observe, our old favourite, it would go orange to green. Okay, well done. Okay, so finally, we're going to draw and name the product formed from the reaction of propanoic acid and methanol using concentrated sulfuric acid. So, what are we going to make? Well, I'm sure you all know it's going to be an ester. So, how can we draw an ester? So, I would recommend we start off by drawing the two reactants. So, let's draw first of all propanoic acid. So CH3, CH2, C double bond, OH, like so. And I'm also going to draw methanol. Methanol, of course, is just this guy. One carbon and an OH group. Now, the way you draw the ester is you start off by drawing the acid. So let's draw that. And then you get to that bit, and then you go, whoa, stop there, Neddy, because we're going to carry on. Rather than draw that O, we're going to draw that O there, and then you can just work backwards with the alcohol to draw him like so. So that is our ester, and to name him, we start off with the alcohol. He is going to become methyl. And then the second part comes from the acid, propanoate, like so. Okay, great.